At this point, it becomes mandatory to introduce two women scientists of those times. One who was very near to the idea of fission, but due to lack of adequate theoretical description, herself dropped the idea. She wrote to both Fermi and Hahn, but her approach was considered too unphysical and absurd and was thus avoided. And the other one, who along with her team ultimately gave the idea of fission, which was backed by chemical evidences and physical explanation. Now we talk about the Hahn, Meitner and Strassmann collaboration, which is the Berlin group. Hahn was an expert in radiochemistry and he met Lise Meitner in 1906 in Berlin. So Lise Meitner was second woman in Austria to obtain a doctorate degree in physics. While Lise Meitner was looking for somebody with experimental experience, Otto Hahn was looking forward for help by a physicist for his research in the radioactivity field. So Meitner soon became a friend and collaborator of the chemist Otto Hahn. This was also a beginning of an extremely rewarding scientific collaboration and a lifelong friendship. In 1912, Otto Hahn and Lise Meitner moved to the Kaiser Wilhelm Institute for Chemistry in Dalhem, a small village of Berlin. Otto Hahn and Lise Meitner discovered the element protactinium in 1918. तो फर्स्ट वर्ल्ड वॉर की बात है 1914 से 1918 के बीच में जो हुआ था, and Otto Hahn had to go and serve in the German army. So what happened was that numerous letters were exchanged between Hahn and Meitner, and they used to discuss their results and their interpretations. When Hahn returned to Berlin, his quest inclined towards chemistry, for which he employed radiochemical methods, whereas Meitner worked on atomic problems. So another thing let me tell you here is that the Auger effect was observed and discovered by Meitner 2 years before Auger published his paper. So despite of the fact that post-war Berlin life was not that easy, but the scientific life flourished more than ever, particularly in physics and chemistry. So this ended very abruptly when Hitler took absolute power on January 31st, 1933, and many of the best scientists of those days had to leave Germany. Aristide von Grosse had worked with Hahn earlier in Berlin on the element 91 protactinium, and he had differences with Hahn. So what happened was that Hahn and Meitner decided to cross-check the identification of protactinium by Aristide von Grosse in the neutron bombardment of uranium. So they employed the method of co-precipitation and found that von Grosse's results were wrong. This task of identification of all activities was quite difficult and challenging because chemistry had to be done with tiny amounts of the unknown activities, and that too in the presence of uranium activity, which is much more intense. So after the results of Fermi were published, Lise Meitner had doubts, and thus she decided with Otto Hahn to disentangle all new neutron-induced radioactivities which were found by Fermi. In this quest, they were joined by Fritz Strassmann in the year 1934, who had come to the Kaiser Wilhelm Institute for Chemistry in the year 1929. His outstanding abilities in analytical chemistry contributed immensely to the Hahn, Strassmann and Meitner collaboration. So the traditional analytical methods of chemical separation and precipitation were followed by this team. All their analysis concentrated mainly on the search of transuranics. And what are transuranics? Elements they thought to be heavier than uranium. So for this, what happened? The products of neutron bombardment of uranium were dissolved and the transuranics were separated from the solution for follow-up. So they neglected the activity of the leftover solute since it contained the dominant natural activity from uranium. Based on their decay half-lives, 9 radioactive species were identified and 3 chains of radioactive elements resulting from neutron bombardment of uranium were proposed. So now we talk of the Paris group. So the inquisitive results on radioactivity induced by neutrons in uranium attracted the attention of Irene Curie and her collaborator Pavel Savich. So instead of chemically separating the transuranes that was followed by the Berlin group, they measured the activities present in the entire solution. They found the known 40-second, 2-minute and 16-minute activities, which were also founded by the Berlin group, and in addition a new strong 3.5 hour activity with beta rays of the highest energy. From its chemical behavior, the Paris group postulated it to be an isotope of thorium in their publication.